One refers to acceleration and velocity and speed. Now, you should remember from last year, what is the difference between speed? Well, let me write it out. Speed, and I'm going to write the word average, and then instantaneous. What do you guys think the difference is?
Instantaneous tells you what it is at a particular moment.
Yeah, so this is really going to be like a distance over time. However, the time is a large time, and so we take an average. But instantaneous is distance over time. But here it's an instant in time. And we'll talk about that from a calculus perspective, how you would do that. So one thing that, so let's look at example number one. Now that we kind of understand that, example number one says in the textbook, a rock breaks loose from the top of a cliff. What is the average speed during the first 2 seconds of the fall? Okay. And then this is our kinematic equation that we would use. Y is equal to 16t squared. And so to calculate this for average speed, so this is kind of a formula for average speed. How would I do that? It wants to know for the first 2 seconds. So what I would do is I'd set t equal to time, right? And calculate what it would be. Now if I wanted to average that though, right? This is actually not quite the average speed. This is the speed that it would be at 2 seconds. Does that make sense?
Yes.
So this is the speed that it would be at 2 seconds. So let's do it like this. What would be the initial time?
0.
And what would be the final time?
2.
2. So let's evaluate this at 0 and at 2 and see what we get. So if I evaluate this at 0, I get y is equal to 16t squared. But I'm going to put in 0 for t, which is 0, right? Because 0 squared is 0. 0 times 16 is 0. So I get 0, 0. Let's do this again. But now let's let t equal 2. And so I get 16 times 4. 16 times 4 is 64. So y represents the speed that the rock is traveling, and at 2 seconds it'll be going 64 units per second. Right? It's actually feet. I don't know if they say that in the thing or not. So what's the average speed? How would I find that?
Divided by 2.
Yeah. To be a little more formal, what we would do is we would say delta y over delta t. Who remembers what delta means?
Y. Split the difference. Y2 times Y1.
Well, yes, you're both correct. The Greek delta in mathematics always represents change or difference. So this would be, we could say y sub 1 minus, or y2 minus y sub 1 all over t2 minus t sub 1. So we're going to let this be our first set. This will be our second set. And so if we plug that in, what we would end up with is 64 minus 0 all over 2 minus 0, which is equal to 32. So the average speed is 32 feet per second. That's the average. And so if we look at this, here's an interesting thing, and this is kind of why Newton needed to kind of make up calculus. We have two opposing views of kind of the same thing, right? mathematically he's able to model the speed that the object will be at, but then again the average speed is 32. So here the instantaneous speed at t equals 2 or 2 seconds is 64. But if I were to average the speed, it would be about 34 feet per second. Does that make sense? And we're saying that's the speed, but really that's the displacement, right? He's really moved 64 feet in 2 seconds. Does that make sense to you guys? Okay. Yes?
Is this a hypothetical equation, or are they?
This is a real deal equation. It looks different to us because we use the metric kinematics. This is the English, the British system. Does that make sense?
No. Why?
Because it's feet per second, not meters per second.
So that's why we're not using gravity. That's my question, like, is this like a